Hi friends, my name is Neil and today let's talk about matrices and determinants. So you may be wondering why bother studying this topic? So why is this interesting, or does it have any practical use in our life? Well, yes. It is an extremely important topic, and by the end of this chapter I hope you will appreciate that it has a lot of practical applications both in science, math, and in also your daily life. So let's start off with introduction. So what is a matrix? A matrix is an ordered rectangular array of numbers. So a few key terms here: ordered and rectangular array of numbers. So they are both important. So order is important, the way in which you write the numbers is important, and then rectangular. Does it have to be rectangular? No, it can also be symmetric, in which case it becomes a square representation. But in the more general case, it is a rectangular representation. And so let's start off with some examples. What is an ordered array of numbers? So you can have something like just the number 7. This is a matrix. It's a 1 by 1 matrix. It has just one element. Or you could have something like this is a rectangular array. You have 2 rows and 3 columns. So this is a rectangular array of numbers. It's a matrix. Or you could have something like the whole set of numbers here is square. All the elements are same, but it is also a matrix. Now, in general, we can write a matrix as this form. The matrix A, with each element starting off from the top left as A11, A12, all the way through A1n. Second row A21, A22, all the way to A2n. And then you keep doing this, come to the mth row, AM1, AM2, all the way to AMN. This is the most general form of a matrix, and it has a dimension or order m by n. Now what do these two numbers mean? So there are m rows. Each of these is a row of the matrix. And there are n columns. Each of these is a column of the matrix. And the most general form of representation in shorthand notation to write this whole big block of numbers would be, you write it as Aij m cross n. So Aij represents a general element of this matrix, where I refers to the ith row in the matrix and j refers to the jth column in the matrix, and m by n represents the total dimension or order of the matrix. Now a few things to note about this kind of a representation. So what does this do? Or you might be wondering, what is A equal to? Well, we need to get this out at the first, that a matrix is simply a representation of numbers. It does not have any value. So if I ask you, well, what is A worth? A is not worth anything at this point. For certain special cases called determinants, which we will come to later on in this chapter, they have a value. But at this point, all you need to remember is A is an ordered rectangular array of numbers. So then yeah, this is kind of interesting, but then what's the practical application? So imagine you're in a situation. You and your best friend or your brother or sister, you have come to visit America for the first time, and you go and meet some new people, and turns out you meet some students here who are also going to high school or will soon be going to college, and you start talking about things about your own country or your own culture. And if you're from India, well, then sports is a big thing there, and you start talking about sports, and your new friends in America, they ask you, well, what's the most common sport out there? And you say, well, we're big on cricket. And then you keep talking about that, and they ask you, well, tell me some good cricket players in India. So then you start saying, well, I love Sachin Tendulkar because he's made the most number of runs in ODI or test matches. Your friend who's traveling with you says, no, I think that Dravid is the best player because he's made the most number of catches in test matches. And your new friends in the US, they're all confused. Whoa. You're telling me Tendulkar is the best player. You're telling me Dravid is the best player. How do we even make sense of this? So, well, you say, let us write it down and show you. And you can decide for yourself who's the best player. So here's an example. So you write down, this is Tendulkar, this is Dravid, and you also compare Ganguly, for example. And so you write down their test scores for one-day internationals. I'm sorry, not test scores, one-day international scores. And here are their lifetime records. But then your friend wants to put in this data point, who made the most number of catches in test matches. So it turns out Tendulkar had 115, Dravid had 210, and Ganguly had only 71. Well, now isn't this easy to compare? So you can explain to your friends, well, look at this data, and if you think that catches in test matches are the best indicator, well, then certainly Dravid is the best player. But if you think that ODI runs are the best indicator, then Tendulkar is the best player. And bam, what you have in front of you is an example of a matrix. So this is a 2 by 3 matrix because you have 2 rows and 3 columns here. So this is one practical example you have seen right here that could be useful in your own life. And we'll see more such examples as we go along. So something to note, a term used in a matrix, again to repeat the generalized version, A equals Aij m by n. So Aij is termed as an element of the matrix. And for example, in this matrix, A22 would be 210. So that's the second row and second column. So it's this number out here. The leading element of a matrix is the first element of any matrix. So leading element is always A11. And if it's a square matrix, if you have Aij n cross n, where m is equal to n, then it's called diagonal elements. Which basically lie along the symmetric diagonal of the matrix. So A11, A22, all the way to ANN. And this is called the principal diagonal of the matrix. So with that, we jump to the second section of our chapter, and that is types of matrices. So there are many different types of matrices, and we can start off with some simple types. So a row matrix, for example, has only one row. So a simple example, this is a row matrix. Similarly, you have a column matrix. There's only one column. Then a square matrix, as we mentioned before, if M equals n, then it is a square matrix. So for example, you can have this is a square matrix. Diagonal matrix, if all the non-diagonal terms are 0. So if aij equals 0 for all I naught equals j, it's a diagonal matrix. As an example, you have, so here the diagonal terms are non-zero, but the non-diagonal terms are all 0. Scalar matrix. So if the general matrix aij m cross n, if all diagonal terms are equal and all non-diagonal terms are 0. So it's for a special case of square matrices. 0 if I naught equals j, and constant if I equals j. So for example, this is a scalar matrix.